Hi guys, welcome back. Today we're going to be talking about rational numbers. A rational number is a number that can be expressed as a quotient or a fraction. You can see that the set of rational numbers is denoted by the letter Q. Here it is written that the set of all rational numbers Q is equal to the set of all numbers P divided by all numbers Q, where the numbers P and Q are elements of the set of integers, and Q is not equal to 0. So what this means is that the set of rational numbers is comprised of all of the numbers which can be made by dividing one integer P by another integer Q, where Q cannot be equal to 0. We call these types of numbers fractions, with one number being divided by another. Fractions have a numerator and a denominator. The numerator, P, is just a number at the top of the fraction. The denominator, Q, is the number at the bottom of the fraction. Now, if you take 2 as the numerator and 1 as the denominator, 2 divided by 1 is equal to 2. The number 2 is not a fraction, but it's still an element of the set of rational numbers. The reason that the number 2 is included in the set of rational numbers is because the set of rational numbers contains all of the integers and natural numbers. The number 2 can still be written as 2 divided by 1, but we simplify that to 2. And for this reason we can say that not all rational numbers are fractions. Here is an example of a rational number. The fraction 1/2 is also equal to 2/4, or 3/6, or 4/8, and so on. Another example would be 1/3, which is equal to 2/6, 3/9, 4/16, and so on. We call these kind of fractions equivalent fractions. Now that we have defined what fractions are, we can start looking into addition and subtraction of fractions. When we want to add or subtract fractions, we must add or subtract the numerators from each other. But in order to do this correctly, the fractions both must have a common denominator. So what is meant by this is the denominator of both fractions has to be equal. Recall that the denominator is just the number on the bottom of the fraction. So here we can begin with an example. So suppose we want to add 1/2 and 3/5. Taken from what we said previously, we must find a common denominator between both of these fractions. An easy way to do this would be as follows. Here we take 1/2 and we multiply it by the denominator of the other fraction divided by itself. Then we take 3/5 and multiply it by the denominator of the other fraction divided by itself. So we get 1/2 multiplied by 5/5 and 3/5 multiplied by 2/2. Now we can see that the results have a common denominator, a denominator which is common to both. In this case, the common denominator is 10. Now that we have a common denominator, we must add the numerators of each fraction. Here we get 5/10 plus 6/10 is equal to 11/10. This is like saying if I had 2 pizzas with 10 slices each, and I took 5 slices from one and took 6 slices from another, I would have 11 slices in total. Now I have 11 slices of pizza, whereas the box originally only had 10. Here is another example where we want to take 2/3 from 1/4. The denominator of 2/3 is 3. So we take 3, divide it by itself, and multiply it by 1/4. The denominator of 1/4 is 4. So we take 2/3 and multiply it by 4 divided by itself. Here we get 3/12 and 8/12. So 12 is our common denominator. Here we can see that adding 3 and 8 gives us 11. So 3/12 plus 8/12 is equal to 11/12. Multiplication of two fractions is slightly easier. So for this, all you have to do is take the numerator of one fraction and multiply it by the numerator of the other, and do the same with the denominator. Here's an example. Recall that in the previous video, I said that 2 brackets beside each other means multiplication. You can see that this is equal to 1 multiplied by 2 and 2 multiplied by 7. 1 multiplied by 2 is equal to 2, and 2 multiplied by 7 is equal to 14. So our new fraction is 2 divided by 14, or 2 over 14. 2 over 14 can be simplified to its equivalent fraction, 1 over 7, by dividing the numerator and the denominator by 2. So here we have 2 divided by 2 is equal to 1, and 14 divided by 2 is equal to 7. In the next example, we have 3 over 2 being multiplied by 7 over 2. Again, for multiplication of two fractions, we multiply the numerator by the numerator and the denominator by the denominator. Here we've got 3 multiplied by 7 divided by 2 multiplied by 2. 3 multiplied by 7 is equal to 21, and 2 multiplied by 2 is equal to 4. Now this fraction cannot be simplified anymore, since 4 cannot divide into 21 evenly without leaving a remainder. When dividing two fractions, you must multiply the numerator of the first fraction by the denominator of the second, and the denominator of the first fraction by the numerator of the second. This is the same as saying turning the second fraction upside down and multiplying. Here in our example, we have 1/2 divided by 2/7. So what we're going to do is we're going to turn the second fraction upside down, and we're going to change the division sign to multiplication. Now we have 1 over 2 multiplied by 7 over 2. This is equal to 7 over 4. Let's say you wanted to divide 9 over 2 by 6 over 4. Now 6 over 4 has an equivalent fraction 3 over 2, but I'm going to leave it as 6 over 4 in this example. If you wanted to make your life a little bit easier, you could simplify 6 over 4 by dividing the numerator and the denominator by 2. So 6 divided by 2 would be 3, and 4 divided by 2 would be 2. So 6 over 4 is equal to 3 over 2. So just like last time, we're going to take the second fraction and we're going to turn it upside down. And we're also going to change the division sign to a multiplication sign. So the last thing left for us to do is to multiply the two numerators and the two denominators together. 9 multiplied by 4 is 36, and 2 multiplied by 6 is 12. So our answer is 36 over 12. Now, since we haven't simplified 6 over 4 into its equivalent fraction 3 over 2, we can now simplify 36 over 12 by dividing the numerator and the denominator by 12. 36 divided by 12 is 3, and 12 divided by 12 is 1. So we're left with 3 over 1, or more simply, 3. Recall back to my video on natural numbers, where I talked about highest common factors. 12 is the highest common factor to both 36 and 12. So that's why when we divide the numerator and the denominator of a fraction by the highest common factor, we get the fraction in its simplest form, and in this case, it's just 3. The reason that we didn't simplify 7 over 4 in the first example is because the highest common factor to both 7 and 4 is 1, and dividing by 1 does not change the fraction. So any time that you want to simplify a fraction, you just divide the numerator and the denominator by the highest common factor. And I did this a couple of times during this video. It is good practice to use simplified fractions, since they are easier to interpret, and it's very easy to keep track of what you are doing within your sum. Here is an updated version of the Venn diagram that we took a look at in the last video. You can see that the set of integers and natural numbers are inside the set of rational numbers. In the next video, we'll take a look at the set of irrational numbers and then the set of real numbers. Thanks very much for watching, and I'll see you next time.